Welcome to part 9, in our new game development series, focused on the 3D Flax game engine, and the 5th in our specific Wolfenstein 3D game tutorial. First of all, sorry for the delay in producing videos, but with Flax Engine being so new, every step that you take toward making a game is an unexplored territory, and a lot of functions that would be needed for a game are still under development or not implemented. This forces us to have to develop new functions before being able to move forward. In the previous video, we have started implementing an animation system for our enemy that allowed us to see as in 360 degrees. We also implemented a very rough and basic artificial intelligence that moved the enemy toward the player. In this video, we're going to implement an AI system with 3 states: patrolling, chasing, and attacking. The enemy will be able to make damage on the player by firing bullets with a raycast. So, without losing more time, let's jump into the action. First, if we are going to shoot at the player, we need to define the shooting animation in our enemy. If you remember, in the previous episodes, the animation for the shooting is different from the other ones that had different versions depending on the angle of vision. In this case, we just have 4 frames. This will be a good opportunity to test our animation system and make sure it is working with all types of animations. So, let's define in the enemy sprite, the new animation, by selecting the UI control element within the enemy hierarchy. Under the sprite renderer class, add a new animation shoot. Unselect the looping and the rotated checkbox, as this animation is to be played only once and always facing the player. For the sprites, the images that we want are in the row 7, column 0, 1, and 2. Now, let's make the changes to the enemy soldier script. Open it from the game source folder. Let's define a couple of variables needed to control different elements of the enemy. First, the physics layers where the player and the grounds will be associated with. Let's define also a health level. After that, a waypoint to be moving randomly the enemy around the level. A bool variable waypoint set to check on if the enemy has somewhere to go. And a waypoint range, that will define how far the enemy will be able to move from the current position. For the attack, let's define a time between attacks. A boolean is attacking to check if the enemy is attacking or not, and a fire point from where the enemy will shoot the player. To control how far it can see and attack, let's define two range variables: the sight and attack range. Again, to keep track of the actions being performed, let's define two Boolean variables to track the status of the player, and it is in sight and attack range that will tell how far away the enemy can attack the player. Let's quickly check if there are any compilation errors. And none at this stage. Let's create the layers that are to be used in the game. For that, in the content browser, let's open the folder settings and then click on the layer and tag settings icon. Add a new layer ground. Save, and exit. Now, in the hierarchy, look for the ground game object and assign it to the ground layer. This will be used to detect if grounded, or if new patrolling positions are on valid ground. Let's go back to our enemy solder script and let's modify the code to bring intelligence into it. The first thing that we have to do is to make some reorganization of the code. In the previous video, the enemy was moving directly from the onUpdate method, and that is not very modular. So, copy all the text associated with finding a point to move and then get the path to it and move. Cut it and replace it with the name of the function that we will be creating next, setDestination. Let's create setDestination with a vector3 parameter that will hold the position where the enemy has to go. Paste in the code that we have cut. Let's go to the beginning of the function and let's start to adjust it to our objective. First, let's rename the function parameter to the destination to be more clear in its purpose. Let's create a private vector3 variable that will hold the current destination. This is important to be able to check if the destination has changed and made changes to the path to be taken. At the beginning of the function, let's check if the enemy has reached its destinations, and if the new destination is different from the current one, in which case, this means that we are not moving, and we shouldn't do anything, so let's return. If not, there is a new destination where we need to move to, so let's modify the current destination to the new destination. In the code, where we are checking if we have reached our destination, let's add the assign true to the variable has reached. In the video, we have misspelled the variable name, so later on we will have to come back and fix it. Look for the line of code where we are setting the target pos variable, and replace the current assignation with the new destination parameter. Let's go to the top of the function and let's add the private Boolean variable has reached and set it to false. Let's go to the onUpdate and let's add into setDestination the target position parameter where to move to. Now, let's add the basic state machines that will have the enemy move between three possibilities of behaviors: patrolling, chasing, and attacking. If you want more behaviors, you just have to replicate the basic mechanism and adapt it to your needs. So, the first thing that we have to check is whatever the player is in sight range. For that, we can use a check sphere with the defined sight range and save in the bool variable player and sight range if the player has been found. We can repeat the same approach to check if the player is in the attack range. After these two checks, we have our enemy able to start taking some decisions that can be represented by checking the values of the two Boolean variables. So, if the player is not in sight range, and of course, not in attack range, then he should be patrolling and try to find the player. If the player is in sight range but is not under the attack range, then the enemy should be chasing the player to try to get into the attack range. And, if the player comes into the attack range, then attack it. If the enemy was attacking and gets out of the attack range, then we should stop any attack on the player. Let's comment out the set destination at the end of the on update and let's start writing the methods defined. We are going to implement first the patrol. There are different possibilities to implement patrols, all of them take into consideration waypoints, but in some cases, the waypoints could be predefined in the level by the game designer, or as we are going to do, by randomly setting a different waypoint across the level. So, if not waypoint is set, we should search for a new one where to send the enemy with a new function called search waypoint. If the waypoint is set, then the enemy should be moving toward it by calling the function setDestination with the parameter destination set as the waypoint. Then, if we come near the waypoint, we should stop and set the waypoint to not being set. This will trigger the process of looking for a new one. Let's now create the search waypoint. To search for a new waypoint, we need to define a new random point around the enemy. For that, since we are only moving in X and Z, we need to generate random numbers between a walking range of the enemy. Flax Engine doesn't come with a random range function as clear and defined as in other engines, so we have to define it ourselves. So, let's create a function random that takes as parameters the lower and upper range of numbers that we want to randomly generate. In the function, we need to initialize the seed for the random generation, and then use it to ask Flax to generate new numbers. Since the generated numbers are in the double format and between 0 to 1, we need to perform a calculation to transform them into the range that we are interested in. We had to check a lot of different references to know what was the correct operation. And finally, we found that the random number needs to be multiplied by the difference between the min and max range and then the total result subtracted by the min range value. Since the random value is of type double, we need to cast it to float before returning. Back into the search waypoint, we can now generate the random position around the enemy. Before sending the enemy toward it, we need to check it as a valid position. By cast array, cast at that position and check if it is ground. If the result is true, then the new position is on walking ground and we can send the enemy toward it. Let's now create the chase, attack, and stop attack prototypes. Before continuing, let's check for compilation errors. We have a couple of them. The first is that actor position is with a capital P. The second one is that the new reserved word should be in small cap. The third one is that, in the random function, we have written private and not private. The fourth is in the definition of had reached, we have not written it correctly. The fifth is at the start of the onUpdate function, where we are calling the do attack that is written with a typo. The sixth is that, when we moved the code to move the enemy out of the onUpdate method, we had the sprite dir variable that stayed local. So let's redefine it out of onUpdate. The seventh is in setDestination, where we have a new type associated with the entry parameter that is destination and not destinations. And finally, the last one, if the one that we commented earlier on, that in setDestination when checking if the enemy has reached the destination, we have written has reached and not has reached. A lot of errors, but when we do large rewrites of code without checking it first, it is possible to make a lot of errors. Before running the game, let's create the object and fill the new references in the enemy soldier script. First, let's create an empty actor in the enemy soldier hierarchy to hold the reference to the point from where the enemy will be shooting. Let's rename it to fire point and let's place it to be more or less where the gun will be in the firing animation. Let's drag it into its slot in the enemy soldier. Let's set the values for the health with 50. In the layers, let's add the reference to the player layer and ground layer. Remember that, as seen in previous episodes, that we have to use powers of 2. Where the position of the player in the matrix of layer and tags. So in our case, the player is in the second slot and ground in the third slot. So we will be using 2 for the player layer and 8 for the ground layer. Let's define now the walking range around the enemy position to 500, which would be 5 meters. Let's also set the sight and attack ranges. The sight will be 300 and the attack range to 350. Let's run the game. And? Nothing happens. Strange. Let's review the parameters from the enemy soldier. Okay, we have not set the ground layer to 8. And let's drag the enemy away from the player. And run the game again. And we have an enemy that is patrolling, moving along the level looking for the player. Let's move the scene view closer to it. We can see that it has finally found the player and stopped in front of it. Let's go back to the code and let's define the chase function. This is very easy to implement, because the only thing that we have to do is to set the destination of the enemy to be the player position. Let's now implement the attack, which will be more complex, because we will have to deal with the animations too. If you remember from the previous episode, the attack animation is not rotating, so the attack or firing animations are in a row. This will force us to check on the details of its implementation. The first thing is to lock the enemy in its position, by sending him to its actual position, which will make him effectively stop. Second, let's keep the enemy facing the player. This is important also because of the sprite animations. Next, let's check if the enemy is not already attacking, in which case nothing would have to be done. If not attacking, then, let's fire a ray cast from the enemy to the player and check if it's hit. For debugging purposes, we are also drawing a debug line in yellow. If the player was hit, that we can be sure by checking if the tag of the object hit his player, we can then perform damage. By getting the script player FPS and calling the take damage function. Once done, let's set is attacking to true. And let's set the ground for repeating the attack at a certain rate. We could have used different ways to implement this fire rate, but we have discovered that Flax Engine doesn't have an invoke function that can be called periodically, as it is the case of Unity and other engines. So we decided to use it, because it gave us the possibility of using threading and tasks in the engine and allow us to take a deeper look into it. At the cost of delays to the video, due to the complexity of its implementation. So, let's call our invoke function, which we'll call reset attack with a periodicity of time between attacks. Let's define now our invoke method. As parameters, we will receive an action that will allow us to call it, and the time between calls. Before coding it, let's first include some references that we need for the function to use. So let's go to the top of the class and add the references to system threading and system threading tasks. This allows us to execute in the background the function and at specific time intervals. Let's go back to the function. Let's define a couple of variables needed to control the overall functionality. Cancellation token source that will allow us to cancel the launch task where we will be invoking the function. A cancellation token that will hold the reference to the right object needed to cancel repetitive function calls. The first thing that we are going to do is to save the name of the function that we will be calling in a dictionary of cancellation tokens. This will allow us, later on, to cancel any invocation by providing the name of the function. If there is already one function running, because we have already called it previously, don't do anything in return. If not, we are going to create a new cancellation token, and add it to the dictionary with the name of the function for future reference. Finally, if the function that we have passed into the invoke exists, let's call it into a new thread while the cancellation token has not been activated. After each function call, we are going to wait for a certain amount of time, by delaying the thread with the same amount of time, and that is reflected by the parameter of our invoke. Let's define now the stop invoke method, where we search the reference in the dictionary and call the cancel method of the token. We have an error that is keeping our all code entry, and that is associated with having an extra closing statement symbol. Let's compile to see for potential errors. And we have a couple of them. The first one, again the wrong reference to player position with a small cap. And second, the take damage function is not defined. So, let's open the player FPS script, which is our player controlling script, and let's create the take damage function. Which is very easy. We receive damage that we want to apply to the player. If the health is bigger than 0, then we will subtract from health the damage. If not, then the player is dead, and we will manage this in future episodes. Let's compile. And we have a new error in enemy soldier. The comparison between the tag and player is missing an equal sign. We are also missing the reset attack function that we used in the first invoke. So let's implement it. It just calls the stop invoke and then sets the is attacking to false. Let's run the game. The enemy is already near us, and we can see that he is shooting at us through the debug raycast, but the enemy is just standing there. There is not a visual reference to the fact that it is shooting. We need to call the shoot or fire animation. For that, let's go the attack function, and let's add to it, SPR play shoot. This will make the animation shoot to be played. We need to fix the code for running animations that don't have the rotation factor. So, let's go to the script sprite renderer. And in onStart method, let's change the way sprites that are not rotated are indexed, in which is discount the gaps that are created by not having 8 different sprites for the same frame of animation. Let's run the game. And you can see that as soon as we run it, the enemy animates itself with the new shoot animation, but stays there. The is because we are not resetting correctly the animation after it has been played, and because we are not taking into consideration if an animation is still being played before playing it again. So, in the enemy soldier, let's add a new code to set the player to idle when not attacking. In the sprite renderer, let's add a new function to test if the previous animation is still being run before launching the next one. So, modify the code in enemy soldier to check first if the chute has finished playing before setting it to idle. Let's check the game. And no, the animation is still being overwritten, plus we have an error. So, in the isPlaying function that we just added, the anim parameter needs to be referred to as the name of the animation and not to its index. In the shoot function where we apply the damage, we are seeing that in some situations the script is not recovered and if trying to run it, breaks the code. So, let's make an intermediate step. Let's first recover the reference to the script, check whatever it is null or not. And then only run the damage in case the reference to the player FPS script is not null. Let's run the game again. And the shooting animation is still being cut before finishing. Let's go back to the isPlaying function. Okay. We are returning the wrong value. We should invert the has finished boolean in case the animation is running because it is not yet finished. Let's run the game once more. And now, it is correctly shooting at us. If we run, it starts chasing us, and if we get out of the range, it starts to patrol. Let's close for this video. In the next video, we will implement the enemy damage and death, and we will also implement the player UI to reflect the suffered damages in the original game. Thanks for watching up to the end of this video, and we hope that you have liked it. If it has been the case, then don't forget to like the video, it is a good way to support our work and to make more people find us. Don't forget to subscribe and to click on the notification button, to be alerted for new weekly videos. If you have any requests on where you want the tutorial to go, any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.